Right, so voltage selection is done via this. It looks like it's had an option here which has been taken out. Slave master unit, I don't know what the story is with those, I've got no idea. Haven't read the manual. So we've got a voltage selection, so we'll change that first. Obviously, because I don't want to blow it up before we even get started. There you go, 230 volts. Fuse, let's have a look at this. It is a 3 amp, which is correct for that voltage. I need to get a smaller fuse in there, but right now I don't have one. Filter looks a little bit dirty. I might take that apart actually and give it a clean. Right, let's get this thing opened up. Okay. Wow. Okay, yes, we do have one issue. There's some big capacitors here, and they've lifted up. They're like a little bracket there as well, and they're supposed to be cable tied. Looks like the cable tie is fractured from age, and they've lifted up off the board. Now these are massive amps, 1000 microfarad, 350 volt. Can't feel any bulging. That's always a good thing. So it's a minor thing. Looks like the brackets are slightly bent from the weight of the caps hanging off them. Maybe it got dropped a little bit when it's being transported. That's possible. Physically, I can't see much else going on. I mean, these cards here look like they're in there alright. So it's very minimal design actually. It's quite surprising. Considering how much is inside the Fluke versus how much is inside this, it's an incredible difference. It amazes me how little is in it actually, to be honest. Very interesting. Have a bit of a look around the unit, so there we go. LM399 reference sitting right there. So it's got a couple of trimmers and stuff around here, so this is obviously the main control section there. It's got some ICs on the back panel there. So it's obviously power supply section. They don't look too bad. There's no signs of obvious bad caps. It's a high voltage section over there. Do not remember what unit is on. Well, yeah, okay. I can't see anything other than these breaking loose because the strap's gone. I mean, so it's not a big deal. Just push that back down again, bring this bracket straight. Ah, there we go. Now we do have a big deal. The reason it's a big deal now, I'll zoom in a bit. It's down behind there is a socket, and it's come off that. Looks like it's actually come off that socket. Well, it's broken. I'm not quite sure which it is. So I'm going to take those brackets off and take that out and have a good look at that before I power that up. Hopefully you can see in there okay. It's not the best bloody... See that little brown socket right down there? Right there? That's not right. So I'm going to pull that apart. Okay, so as you can see I've got the first nut there off. Star washer still on it. I'll try and get the second one off. I don't have a long reach socket I'm getting here with, so I'm just going to use my little pliers here and we'll just get this in. That's not the best situation. I've probably got something somewhere, but for now I'm just trying to use this. Although these aren't the best things to get into either. This one's a bit awkward. But what it's got in here is like studs mounted to the bottom panel. I do have a 6mm socket, right, which is close. It's not actually exactly right, but it can't get into there because it's got a square drive and I've got to sort out a square drive for it in order to get into it. Right, so I've discovered this handy little detail, and that's that the nut is the same size as one of these typical screwdriver bit attachments for drills and stuff like that. So if I shove that in here, I should be able to do it with this, in theory. Hey, look at that. That's much easier. Cool. That was convenient. Okay, let's get this thing out. Obviously these aren't charged because it's been unpowered for weeks, so it should be fine. Let's get these little star washers off before I drop them somewhere. Okay. So you can see those brackets are bent quite badly, as is that. There, that should be straight down. It's also bent slightly, but doesn't appear to be fractured. Hopefully the bottom of the board isn't damaged because it's a bit of a mission in getting it out because you've got to take everything off. So let's just try and straighten these back up again. To at least be close to right, I suppose. I might have to take those off completely actually and try and get those straight. Actually, I might be able to spin it around sideways. Maybe, we'll see. Anyway, I'll figure it out. These are massive caps. Size of these things. 85 degree though. Anyway, I hope these don't need replacing, that'd be expensive. So the bracket on here is bent. Doesn't feel loose, so hopefully it's okay. I've just bent the pins and not actually fractured the circuit traces underneath. So I shall do that, and so there's our studs there. So to get this board out, to fix it if it is damaged, I've got to take every single mounting nut off this. I've got to take everything out to get the board out, because it's attached to the bottom panel. So that's quite a mission. I don't really want to go there if I can avoid it. Alright, so anyway, let's fix this bracket up. We'll get this sorted out, then I'll put it back in again, and we'll try powering it up. So I was trying those brackets out, but I was having a close look at this connector here. And the very end pin, get the light on it right, maybe it'll show up, I don't know. It's got a little line around it, so I think that one's actually cracked. So I'm going to take these capacitors off and resolder all this, and then we'll put it back together. Okay, so I've got my fake Heiko warming up. We'll give that a try and see how it goes. I'll probably just resolder all the joints. That wasn't very tight actually. Anyway, let's see how we go. Mustn't forget polarity. Polarity. Alright. Are they marked at all? They're not. Interesting. I've got to be really careful with this then. Let's mark these. Otherwise I might make a mistake, and that would be really bad on this size capacitor. Let's get a pin. Oh, there we go. There's one right there. It's convenient. Alright, so top. There we go. Can't get them wrong that way. I'll probably test these too, just to be sure, but my tester probably won't even touch these things, and it's pretty big values. So let's have a look at this board. I don't know if you'll be able to see it on camera or not. Trying to get some better lighting. There's a little crack just around that one there. You can just see a little line. Hopefully, I get the light on it just right. You might see it. There you go. So I think that one's cracked. So I've resoldered a whole lot. Seems not a big deal. It's pretty old circuitry, so we'll find out how it handles the resoldering process. We'll see how this iron goes. It's currently set to 300. Don't know what you can see, but anyway, I'm currently standing up instead of sitting down because I've got the actual unit on my chair. That's resoldering right. That's fine. So there's a bit of a shame it bent, but it's kind of straight now. I've managed to get it straightened up a little bit, but trying to see if there's anything else that's on there which is potentially bad. The rest of the joints look fine. Just retouch this one. We shall clean this up, put the capacitors back on again after I've tested them, and we'll go from there. Right, let's measure these caps and see what's going on here. See if these are okay or not. Right, ESR 106, that looks alright. I don't think it's 1000, and that's what it's come up with, so that's good. Let's check it on. This is at 1 kilohertz. 993, yeah, okay. If I change to 100 hertz, 106, I mean, yeah, it's fine. It's alright. They measure right. I mean, usually I do larger caps at lower frequency, but you know, anyway. Yeah, I mean, it measures fine. And I tend to run at line frequency. For me, just 100 hertz. So if I'm doing big power supply caps, but yeah, I mean that measures fine. So they look okay. I'll put it back together. Alright, so the capacitors put back together. Now, before I put them back in, I'm going to need to get another cable tie through. So I've got one pushed through. It's almost coming out the hole, so I've got to try and fish it through. So at least I can try and get it through there without having to take the board out. At least that's what it looks like. So I can try and get the end hooked over. Maybe I can grab it with tweezers if I'm lucky. If I'm lucky. Yay, gotcha. Excellent. So that's good. It's one thing I don't have to worry about trying to sort out. It's always great fun, isn't it? Right. Stick that on there before I lose the end. So that should be able to go around the caps, and I'm better tie that back up. So those should pop onto those pins quite nicely. Pins and onto the mounting bolts at the same time, which could be the tricky part, trying to get the whole lot lined up. The pins have gone on, mounting bolts have gone on. Cool, that seems right. Will I risk doing this up yet? Yeah, I think I should. There we go. Alright. You can sometimes actually unpick the latch. You can just get something in there and you can actually release them again if you're careful. So, anyway, I'm just going to leave it like that for now. Let's get those bolts in there. And, well, those nuts back on there with the star washers. This is where tweezers come in handy if you get into these little spots. And I still got it wrong. Okay, it's a bit awkward working around everything, so I'm going to come back once I've got those back on. Okay, let's bolt it back in again now. So that's nice and solid. Let's just carry on having a bit of a look around, see if I can see anything else which may have been an issue. But I think it's all looking good. Nothing looks like it's loose. I can't see anything burnt. I'm fairly confident that there's nothing at least obviously wrong. I can't see any brown tantalums. That's always a bad sign. So anyway, we'll give it a go. All these switches here look like they need a good clean. There's a bit of oxidation on all the contacts, but we'll try it out first before I worry about doing anything with those. Right, I've got the power plugged in. Moment of truth. Let's power the thing up for the first time and see what happens. Okay, the fan has got something jammed in it. Right, let's fix that first. There's a offset, there's a standoff in there floating around. Where did that come from? That's in there. Little standoff. Right, let's figure out where that's from. Very interesting. I don't think it could have fallen from somewhere outside of the unit. And I don't see any other standoffs in here, apart from on this shield here. Trying to determine where this came from, but I don't see anywhere. Oh, I'm sure it'll turn up. That mystery will be solved at some point. It could be from that shield, but no, they're different length. They're shorter. That's shorter than those ones on this shield here. These are quite long ones. I don't think there's a missing shield. These transistors here are interesting setups. Don't know, they seem weird. Anyway, okay, well, nothing obvious, and this is from the behind the front panel there. Right, let's try it again. Right. Fan's awfully noisy, I'm afraid. Let's move the microphone. So let's just hook up some probes on here and we'll see what we're getting out of it. So it's at 12 volts, it's on standby, local, 100 hertz, so 1 kilohertz. Oh, auto ranges. But auto ranged up anyway. That's interesting. It does, auto ranges upwards. It's pretty cool. Alright. Well, let's stick some probes in here and we'll see what we're getting out of it. Obviously it's not the best setup. There's no straps on these for the reference. Those are the sense lines. Remote sensors turn off, so I should be using internal sense anyway. Just turn it on, shall we? That might help. So at one point, let's try and get these wires out of the way so you can see. 1.0222. 1. 1.021. It's close. Bear in mind nothing's warmed up yet, obviously. 12 volts. So it should be 10 volt range. Again, close. What I'll do, I think, is I'll change these probes around. Because there's no sensing bars on there, I might have to get some of those little bars to put on to strap them together. That may or may not matter in this case, I'm not sure. Of course we'll get hooked up. Let's try this again. Definitely got to change the fan. It's horrendous. So 10 volt range is where I was. Remember it's the last setting too, which is quite nice. So let's change frequency, 100 Hz. I mean, it's there. 100 kilohertz. Yeah. I mean, it's definitely kind of there. 10 kilohertz, I can actually hear that whining. Wow. Okay. 120 volts. Yeah, so doing 100 volts output. Hey, it's a lot closer to working than the Fluke was when I got it. And it's got the indicator lit up on here to say it's dangerous output voltage, which is nice. 1200 volts. And that's gone to standby. Now what I might do is drop this down a bit. There we go. And it's gone back to standby again. Why is it not doing the higher voltage range? So 100 volts there, okay. 200. 300. Now it's tripped out. Gone back to standby again. So there is an issue here. I won't do it up above 300 volts. It's back to 200 again. And we'll just work our way up to it and see if we can find a point where it stops working. Let's go 250 first, though, halfway. Still in 250. Yep, it's got an issue. Now, is it a range selection issue rather than a voltage output issue? I don't think so. Yeah, I mean, it seems fine on that. It just seems to be high voltage, above 300 volts. It's dropping off. So, yeah, okay. Well, that seems kind of alright. 0 volts. Going to do 0 volts. Yeah, 1.12 volts. I'm not using guided cables. You know, there's no shielding. So it's not perfect, but it is mostly working by the looks of it. So it's just at above 300 volts, which is going to be an issue. Let's try a different frequency, and we'll go again. We'll see if we can get it with a different frequency instead. Yes. Really got to change that fan, that is awful. Alright. No, that's not 500 at that frequency. So, okay, let's go lower again. No, it doesn't like 500. Let's try a higher frequency then. If I choose those. wonder why I can't choose those ones. Is it because of the voltage I'm on? It does seem that way, yeah. Okay. So I can't choose those high frequencies at the higher voltage range. You can only do up to 1 kilohertz in that high voltage range. So okay, that's alright. Remote sense on off. Not going to drive it nuts. Let's do 12 volts. Let's do 10 volt output at 50 hertz. Put it on. So pretty much there. Turn on remote sensing. It's jumped up because it can't sense what the voltage is. So that's fine. That's working as you would expect. I think if I had the jumpers on the outside here, I'll probably get in a more accurate voltage. Right. Well, it's kind of working. Obviously I need to figure out what's going on with the high voltage range. Right, so we're doing some trending on it and it seems to be okay. These big ones up here, up and down, are me changing the ranges by 100 microvolts, which is the minimum range on this thing, and in this particular setting at least, and it was changing by that much. So it's not bad actually, it's better than the Fluke. So one thing I just noticed is now looking around it, if I can get in there and show you, just here, C122, you might notice a small problem there. It's not there. There is a component leg sticking out one side. I'm going to have to investigate that to find out what's going on there. At least that particular board looks like it's fairly easy to get out. There's a few screws and it will lift out. So this is the high voltage card here. Well, it's providing that high voltage for the 1000 volt range, I'm guessing. It's also got these other transformers down there as well. GPRB card in the back. So obviously this is a processor card here. It's got an EEPROM here. Date on it is 93. There you go, 11th for the 12th, 93. That's the year it was probably made then. Or someone's upgraded it at that time, I'm not sure. But probably should have started recording this a bit earlier on, but I've been starting to repair these Valhalla handles because they're all in pieces, all broken off. All the bits were here, so that was brilliant. Remember, some of them was taped together on the front when I got the unit, and the other ones were smashed inside the packaging. But I've already reassembled one with a fair bit of glue, and I'm just in the process of doing the other one. This one looks like it's all complete too. So this is the last stage now, is to actually put all the broken bits back onto here, and that's all looking good. There's a couple of little chips out of it, but yeah, it's all there. Now the good thing about this is it means that I can I've got something to measure, and I can then try and make a 3D print of this. I've purchased a printer. I've not done 3D printing before, so it's going to be a bit of an interesting exercise for me. So I've got to do 3D design, 3D printing, and figure it out as I go, which is alright, it's fine. Once the 3D printer turns up, I've ordered some ABS filament for it. This is probably ABS, so I basically want to remake this but stronger. Thing with this has got these threaded inserts in here, so that could be a little bit tricky. I might have to try and see if I can 3D print in a nut or something. Put some nuts in there. You wouldn't want to pick it up with these. I certainly wouldn't trust them to not fall apart when you're carrying it, because that'd be really bad. I doubt I'll ever use these anyway. Regardless of that, I still want to try and store them what I can. So I want to get a 3D printer, and I purchased it, and I purchased filament, and then I've got to learn how to use it and learn about 3D printing. It can't be that hard. As I have a background in plastics, understanding it should be a bit easier, because I actually understand plastics and how they work and what issues they have and how to fix those issues. So that part of it should be easy. Getting used to the equipment and the software and stuff like that's a bit harder.